Hi students, this is going to be the final video for a review of trigonometric graphing. So I'm going to try to do two in this one, so I'm going to go a little bit more quickly. Alright, so this guy is clearly a tangent or a cotangent. We're going to write at least one version for each. So I see that cotangent's probably going to be easier because it starts not straddling. So we've kind of got it starting in that first fourth quadrant area. Looks like we've got an asymptote there, and we've got an asymptote here at 4 pi, so clearly the period is real easy to identify on this one. Period is going to be 4 pi. These don't have an amplitude since they're tangent or cotangent, so that's pretty easy. What other transformations can I identify? Looks like it went up to this spot in each one, so it looks like it's up by 8. Anything else? If it's cotangent, I think it's ready to go because cotangent always starts by going down like that, like these purple curves are doing. So my first function version here, I'll call it, you know what, I called the last one f. Let's go g on this guy. So let's call this g sub 1. So my first version of this graph is going to be, it looks pretty normal too. I don't see any stretches or compressions, so I'm just going to say good old cotangent. I've got a period of 4, so 4 pi, so I need to go like pi divided by something, sometimes we call that b, in order to get 4 pi. So I think if I put a quarter there, that'll flip up, so I need to put a quarter in here. You can actually go ahead and solve for question mark there if you want, but I'm not going to. It's just easy to do in my head this time. So I'm going to say a quarter. If I divide pi by a quarter, I'll get 4 pi. Okay, so then that's going to accomplish the correct period, and I need to go up by 8. So you know what? I don't even have a phase shift here. I'm just going to say x. There we go, plus 8. There is one version of this function. Let's get another one and put it in green. So g sub 2, what's another version of this function? Let's do a tangent. So this time I'm going to say tangent. I want the same period, of course, but I probably want some kind of transformation there. So how do I want to do this? If I want to do tangent, then it's going to need to shift so that this is like centered. So tangent would need to like shift an asymptote that would have been like right here to right there. So that's going to need to go like minus maybe 2 pi, looks like to me. Yeah. So if we went minus 2 pi, I would take the asymptote from 2 pi and shift it to the right by 2 pi. And of course, this is also the wrong way for tangent, so I think I'd also need to go like this. So there's a correct tangent graph for this one. Another correct tangent graph, I think, would be almost identical. You could do negative tangent and, you know, put your 1/4 in there, and you could shift it other directions. So I think you could take this asymptote right here and shift it left by 2 pi. So you could go plus or minus 2 pi. So I'm going to say that's another version. So that's g sub 2 and 3. So this guy would be really g sub 4 and 5. So let's see, couldn't you also take this asymptote and instead of shifting it to that one, couldn't you shift it all the way to this one and go from there all the way to here? So that would be taking it from 2 and going to 8. That would be like minus 6 pi. So that's another possibility right there. And I think you could do it the other direction as well. So plus or minus 6 pi would also work. Okay, so there's that one. I think that one was pretty easy. Let's look at this one down here. I don't want to use blue this time, so I'll start out with red. So clearly this is either a secant or a cosecant. Which one is it? Well, first I need to identify the center because it looks like it's been shifted down. So the center doesn't look like it's too sneaky. Looks like it's about right here at -3. So I think I'm going to have down 3. So let's just remember that. Maybe I'll write it down just for reference. So we've got down 3. What's our period here? Well, we've got one starting right up next to the axis, and then the other one looks like it's done by about right here at 1. So the period looks nice and easy as well. That's going to be just 1. Anything else that we have to worry about? I can't really tell too much. Oh, let's see. How far is it going up and down? So it looks like this distance is just 1, right? From -3 to -2. This distance is just 1, so I know that the amplitude of my guides is also going to be 1. Okay. So there we go. I think we just are ready to start assembling. So what would be easier here? Well, I think be a little bit easier, let me grab my green, if I think about this one first. So I'm just going to draw this kind of guide function in there. So you can draw your guide in, right? So that looks like a sine wave. So I think a cosecant would be easier here. We got an amplitude of 1. We need to make its period be 1. So let's think about how we can do that. So if we go 2 pi, what can we divide by to make that come out to 1? And I think that the answer is pretty obvious there. Question mark must need to be also 2 pi. So that's pretty easy. All right, so let's come up with our first graph. So first function rule. First function rule, you know what? I keep wanting to say f, so let's go h on this one. So we'll call this function h. Version 1 of h is going to be an amplitude of 1, so I'll just put 1. We said sine would look good. Sine's partner is cosecant. So I'm going to go cosecant. I need to put 2 pi in there to achieve the correct period of 1. And if I don't phase shift it at all, I'll already have it be exactly right. So I think I'll just go like this, down 1. And there you go. So there's one version of the correct function. Let me get another color and we'll do another version. So let me see what other colors I have available. Do I have something else that I can use? Yeah, I have like a yellow or something here. Let's go with a purple. Okay, so let's look at a second function. So I'm going to say h2. So h2, you know, I'm going to try to make a secant function for this. So if I wanted a secant function, then the secant curve, and let me clean this up a little bit here. The secant curve would have to be somewhere in here. Okay, so there's cleaned it up a little bit. All right, so the secant curve would have to be somewhere like this, right? So I need to move my secant curve that way a little bit in order to get it to go. So how far is that? It looks like that is 1/4. So if I go secant and I go 2 pi and I shift that to the right by 1/4, not pi, just 1/4, one regular quarter. And I keep getting this little aberration here. I'll try to stop that. If I go 1/4 that way, I think I'll have a function that will work. Let's see if we can come up with one more or two more maybe. So a third function that would work. What would that be? Another secant that I could get to work might be if I could, maybe if I did a negative secant. No, let's just do a positive secant. So then I could also get it to be like right here, right? So how far would I need to shift it to come all the way over to there? So that'd be 1/4. So this would be like secant. Then we'd have our 2 pi, of course. And then we'd have x minus 1/4, or 5/4. So that would also work. Let me just see if I can come up with a couple more since we've got time in this little video. Let me come and do an orange one. So let's do a fourth option here in orange. Should we do another cosecant function? Yeah, let's do another cosecant. So what other cosecant could we have? Maybe, yeah, maybe a cosecant. So instead of going like right there with the regular one, we could actually have the cosecant move from the beginning and go all the way to here. So we could go cosecant of 2 pi, and we could go like x minus 1. And of course, you could also think about going backwards and trying to do some negative ones and so forth. But I think that's about the level you were supposed to hit for these first few introductory functions. I hope that helps, and hopefully you're able to do your assignment now. If you have questions, just be sure to come ask me. Don't be afraid to bother me in class or to ask Miss Holloway. See you later.